Okay, guys, there are a lot of questions. Are you all on this page? There are a lot of questions on valence electrons. So valence electrons are electrons on the outermost or highest energy level. We did this exactly. The maximum number of electrons that an atom can have is 8. So, kids are asking me how to determine the number of valence electrons. Alright? There are two ways to do it. Let me teach you the shortcut method to determining the number of valence electrons. Alright? So you may draw a periodic table and group 1 elements have how many valence electrons? 1. Group 2 has how many valence electrons? 2. Group 13 has 3. Group 14 has 4. Group 15 has 5. Group 16 has 6. Group 17 has 7. And group 18 has 8. Yeah, the D block elements generally have 2 valence electrons also. Alright? F block also has 2 valence electrons. How does this happen? So valence electrons are supposed to be the electrons in the outermost energy level. Is that right? So all these elements will end up with an electron configuration S1, which is the highest energy level that they will have. Is that right? So if you come to group 13, all right, let's look at aluminum's electron configuration. If you look at aluminum, the electron configuration will end in 3s2, 3p1. Is that right? The energy level is still 3. Yes or no? The highest energy level is 3. What is the total number of valence electrons? 2 plus 1, 3. Does that make sense? So for all group 13 elements, it's the combination of the S and the P that makes the valence electrons. Does that make sense? I think having done aluminum, you understand what it is for all the way up to group 18. Is that right? Group 18, if you take neon, it's going to be 3s2, 3p, and 2s2, 2p6. So 6 plus 2, 8 is the number of valence electrons. Is that right? Now, for a D block element, why is the number of valence electrons 2? Alright? So, there are a few things you need to understand if you are looking at a D block element. Alright? Can I use a fresh page somewhere here? Okay. So, how do the electrons go into the different energy levels? So this is the positive nucleus, all right? You say your S is spherical. Pardon me, I'm drawing on a two-dimensional region of space. This is the best I can do, all right? This is your 1s energy level, which is the lowest in energy. Is that right? Then you fill in the 2s, which is also a spherical orbital. It's slightly higher in energy. Is that right? Now, after the 2s, you fill in the 2p, and the 2p looks like a dumbbell. Is that right? Is that right? And there are 3 2p orbitals that fill in, and that's the next energy level that fills in. After the 2s and the 2p's, let's say this is 2px, 2pz, and 2py. All right? After the 2p, you fill in the 3s and the 3p. Yes or no? This is how the electrons fill in. So you have the 3s and you have the 3p. Now please bear in mind, the energy levels get closer and closer as you move further and further away from the nucleus. The energy difference is very wide between the first and the second energy level, slightly more wider between the second and the third energy level. But then the energy difference starts to diminish. Yes or no? We've seen that in the energy level diagram. Yes? Okay. When you come to the 4, after we finish the 3 energy level, when you come to the 4s, All right? You still have the 3D, which you haven't filled up. Somehow you fill the 4s before you fill the 3D. Yes or no? So you fill in the 4s and then you start filling in the 3D, right? The 5 energy levels of D. Yes? Why do you fill in the 4s before the 3D? Now, energy level depends on how much is the attraction of the nucleus for that electron. Do you agree? Look at the shape of the cloud. It's a sphere. And the nucleus is sitting in the center here, trying to attract this electron which is in the sphere. It's a wider region where it can cast and pull. All right? So what does it do? Because of the wide space where the influence of the nucleus can be felt, moreover it's spread out, the 4s becomes lesser in energy because of the shape of the orbital. But if you go to 3D, 3D is something like a flower petal. Yes or no? Does it look like a flower petal? Do we draw D like this? Right? Like a flower petal? Now, the nucleus in the center is trying to attract the electron in these narrow regions. It's not able to pull it as effectively. Therefore, 3D, because of the shape of the orbital, becomes slightly higher in energy than the 4s. Does that make sense? The 4s is spread out, the nucleus can pull, the energy level lowers. The 3D is very narrow, the nucleus energy is not felt, so it increases in energy. But the distance also matters. The 4s and the 3D are pretty close to each other. Is that right? But because of the beautiful shape that 4s has, its energy lowers. It can feel the effect of the nucleus. Does that make sense? But now we are coming to the valence electrons that are in the d orbital. We talked about how we fill the 4s and then we fill the 3d. Is that right? Why do we still say that the number of valence electrons that d orbitals have is still 2? You are trying, valence electrons are very important to know when you especially try to remove or add electrons to the given element. That is the idea of a valence electron. How much does it have? Did we talk about octet rule in this class? Did we? We should have talked about octet rule. Yeah. What is the octet rule? All elements like to gain or lose in order to have 8 valence electrons. Octet meaning 8. Do you remember John said October? October is the Roman naming was wrong. I remember that discussion in this class. Yeah. Okay? So, they all want to have 8 valence electrons. Is that right? Now, so elements either lose or gain. Is that right? Now, try and imagine that you are trying to remove an electron from an element in which the d orbital is getting filled up. Remember, the d is very, very narrow. I'm going to draw a narrow d orbital here. Are you all with me? Yes. Are you all with me? So do I shade in this d orbital and show it as a narrow d orbital? Are you with me? All right? So tell me, and I haven't really shaded my blue. My blue is my whole sphere. Yes or no? This whole region should be blue, right? If I'm trying to remove an electron, now, if they are metals, they generally lose electrons, so that their inner shell has 8. Yes or no? Did we talk about this before? Tell me, is it easier to remove from the wider 4s orbital when you try to remove, or is it easier to remove from the really narrow d orbitals? which is easier to do? The wider, right? This is the space you're trying to grab and remove. From which one can you remove easily? From where it's easily available, all over. Instead of trying to go and narrow it down to a small region of space. Is that right? So which two electrons will be lost first? The ones that are in the 4s. Because they are more easily accessible because of the type of orbital they are in. So all d orbitals, all elements in which d orbital is filled, which electron is lost first? The ones from the 4s. Once that is knocked out, then they go into the d orbital. Does that make sense? Okay? So they all have how many valence electrons? If they filled in their d orbitals, I mean their 4s orbitals, not 4s necessarily, any s orbital, they have 2 valence electrons. Does that make sense? Do we understand this? Okay. Let's go back to our notes. Did we finish this page? Did we finish this page? Not the bottom? Alright. Noble gases are unreactive because they like to have 8 valence electrons. Atoms and ion forms by adding or removing electrons in order to mimic the noble gases. They do not become noble gases because of the number of protons has not changed. This is known as the octet rule. Alright. So let us compare the electron configuration of lithium. Now I know why Lucy is participating in class. Alright. So it's 1s2, 2s2, 2. Wait. Lithium is 2s1. Is that right? 1s2, 2s1. Do we get that? Okay. If you do sodium, it's 1s2, 2s2, 2p6, 3s1. Do you see the 3s1, the 2s1? All of them have exactly 1 electron in their outermost energy level. This means they all have exactly 1 valence electron. The elements in group 1, will they like to lose or gain? They like to lose because then they have how much in their inner shell? 8. Alright, they like to lose 1 electron in order to become a stable. Once they lose an electron, what is the charge they will have?
+1.
+1. Okay? So that's good. Anybody else wants to be in the video recorded? Why don't she achieved her objective. Alright. Okay. So let's go ahead and write out the valence electrons. Shall we? So this is 1, 2, 3, 4, 5, 6, 7, 8. And oxidation state, kids often get confused with this term. It means nothing but the charge.
+1.
Alright, very good. So it's +1, +2, +3, ±4, because 4 is halfway of 8. This will be what? -3, -2, Are we good? Okay? So we are now, so we did this before, is that right? So argon has 18, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. If this were an ion with a charge of -1, did we do that? Did we do what it is? So argon has 18. Please look at the periodic table. Alright? Please look at the periodic table. Argon has 18 electrons. Which will gain 1 more and become 18? Which element can gain 1 more and become 18? Chlorine -1. Alright? Do we see that? So chlorine -1 can gain 1 more and have 18 electrons. Which can gain 2 more and become 18? Sulfur. Which will lose 1 and become 18?
Potassium.
Which will lose 1 and become 18? Potassium plus 1. Which will lose 2 will be calcium. Is that right? They all have the same number of electrons. Is that right? They all have 18 electrons. They are called isoelectronic of each other. Iso meaning? Same number of electrons. Same, in this case, same number of electrons. Isobars, same pressure. Isotopes, same number of protons with different number of neutrons. Yes. Huh? You want get me something? I can find a pass for you. Okay. So now they want us to write the electron configuration of. Okay. So guys, this is interesting. P minus 3 is similar to which element? Argon. Is that right? Does it have 18 electrons? P minus 3 is 18 electrons. Yes? Is it the electron configuration of argon? So it's going to be 1s2, 2s2, 2p6, 3s2, 3p6. Are we good? Okay, here comes the hard part. And I need my students to listen, understand this. Iron is making a +2 ion. All right? Where will it lose its 2 electrons from first? We talked about this just a little while ago. Where will it lose from? 4s. So write out the electron. Do you want me to write iron first and then write iron plus 2? All right. Let's just do iron here on the side. All right. Iron is 1s2, 2s2, 2p6, 3s2, 3p6. You would, for a neutral one, you would do 4s2, 3d, iron is 1, 2, 3, 4, 5, 6. Is that right? Yes or no? Now it's losing 2 electrons. Where will it lose its 2 electrons from? From the 4s. This gets knocked out. Alright? So the electron configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 3d6. Does that make sense? Alright. Now it's losing 1 more electron. Where do you think it will now lose its 3rd electron from? From the 3D. Oh, this year I'm having a lot of success. Hopefully this is not a missed question this year. 1s2, 2s2, 2p6, 3s2, 3p6, 3d5. Are we good? Alright? Shall we very quickly go back and do it for silver now? Shall we do it? Yes, Karen. It's not the outermost energy level, but it's so widespread that when you're trying to pull the electron out, it first goes out of the 4s, and then it comes out of the narrow d orbital. Alright? Now, let's go back to the, did I cancel the warm-up out? What? What? Hannah, what's the question again? In which element are you talking about? Yeah. So if it were just phosphorus, it would just be 3p3. Phosphorus ends at 3p3. Because it's -3, the 3 has become a 6. It's similar to argon now, the electron configuration. Does that make sense? If you write 3b3 for phosphorus minus 3, the answer is incorrect. Yes, Rochelle.
This is just for elements in the D block.
Yeah, the D block will lose the 4s before the 3d. When it comes to the S and the P block, when you're making ions, it will lose the S. If it's the P block, it will first lose the P. Why? Because the S and the P orbitals are very wide in energy from each other. When it starts coming to the D, they become very close to each other. That's when all the confusion, the shape, everything kicks in. Kate and then Kairos. Yes.
Does it go for the other ones too, like for the side S and then the 4D?
Yes, yes. Even when you go into the 5s and the 4D, it will first get removed from the S orbital before it gets removed from the D orbital.
And does that happen in the F?
F, you will see a lot of exceptions. That much exception is beyond the scope of this class.
So we're not going to do like
We are not going to do a lot of that.
Okay.
All right? Yes, Kairos.
So is iron here trying to be found
Remember, first off, if you're talking about the valence electrons, it only had 2 valence electrons to begin with. When it makes the iron plus 2, its 2 electrons are already knocked off. And you would say that this is, well, even though you talk about the octet rule, all right, even though it's widely said, right now it really doesn't apply that well in this D block elements. Is that right? We talked about the 2 and we removed the 2. After that, it becomes a little murky to still keep talking about it. Does that make sense? Okay? So let's do silver. We were going to do silver, and I said it's one of the most missed questions. All right? So silver is a +1. They had given you silver +1. Is that right? So when you're writing the electron configuration, which one do you think will vanish for silver +1? The 5s1 will vanish when you write your electron configuration. Does that make sense?
Yeah.
Does everybody understand that? Yes, Lucy.
Then does it also vanish in the noble gas configuration?
Yes, when you write the noble gas configuration or the orbital diagram, it will vanish. It will vanish from the noble gas configuration if you're doing it for the +1. Does that make sense? Are we good?
Yep.
Okay. Now, moving on. All right? Moving on. This is the easiest thing to do. Draw dot diagrams. All right? Especially when you're learning elements. All right? So, all you do is you find the number of valence electrons and you draw that many dots. So, sodium is in group 1. How many valence electrons? 1. Draw 1 dot on top of the, write the symbol and draw a dot on top of it. Magnesium has how many valence electrons? 2. Now you draw dots like this. You draw dots in the 12 o'clock, 3 o'clock, 6 o'clock and 9 o'clock positions. Aluminum is 3, so that's 3 dots. Sulfur is 6. 1, 2, 3, 4, 5, 6. Now in this 6, tell me how many paired electrons does it have? How many single electrons does it have? 2 single electrons, all right? Chlorine has 7 and argon is complete. This is called, as the name says, it's a dot diagram. Do not get confused between Bohr model, orbital diagram, and dot diagram. Does that make sense? As the name says, dot diagrams is asking you to draw dots. So going back to your warm-up, all right? Going back to your warm-up, it says, draw the dot diagram for arsenic. Arsenic has how many valence electrons? Arsenic has how many valence electrons? 5. So I would write arsenic 1, 2, 3, 4, 5. Do you understand? That is the dot diagram for arsenic. And this is an ion, so we don't draw dot diagrams for ions. We're not interested right now. Okay? Are we good? So we never answered this question. Arsenic has how many valence electrons? 5. So what kind of an ion will it form? Look at the group. Will it like to gain 3 or lose 5? Gain 3. So if it becomes a -3 ion, isn't that group 15 has a charge of -3? Did we not just write it down? Guys, some students are looking at me as if I'm talking Greek. Arsenic is here in group 15. Yes or no?
Yes.
Did we say it has a charge of -3? Did we just conclude that? By looking up the group number, by looking up the valence electrons, can I decide what the charge will be for the given metal ion or non-metal ion? So if it's a negative charge, is it a cation or an anion? It's an anion. All right? Now they want you to write the electron configuration of arsenic, which will resemble which element? Arsenic -3 will resemble which element on the periodic table? Krypton. Yes or no? Arsenic -3, As -3 will have 36 electrons. Yes or no? Instead of 33. Yes. Arsenic will not make +3. Arsenic will only make -3. It adds. Minus is adding electrons. It's gaining 3 more electrons. Right? Because the negative comes from the negative charge and the electron. Correct? Alright? So it's going to be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6. Is that right? And that is the electron configuration for argon. Krypton. Is that right? Are we good? So you should know how to answer all these pay attention to all these little nuances that are in the question and answer them correctly. Are we understanding it all? Okay. Now moving on. I think you can do yourself krypton's electron configuration. You know to do. I'm going to move on. All right. The last one. All right. N notation. Now, N notation is easy. All right. So if I draw a periodic table, all right, I know all my elements have 1s1, 2. The last electron configuration is ns1, 1s1, 2s1, 3s1, 4s1. Is that right? Isn't that how it enters when it's in group 1? Is that right? So I can say, instead of 1, 2, 3, 4, I can say the general electron configuration is ns1. Do you agree? For all elements in group 1. Can someone help me with the N configuration for group 2? ns2. All right? So what do you think it will be for group 13? ns2 np1. Is that right? Right? It gives me the number of valence electrons, guys. It helps me count up the valence electrons. Right? So what is that for group 18? ns2 np6. All right? So I'm not going to write the abbreviated configuration. You can do that. Right? You know how to write the abbreviated configuration? I'm lazy to do that. All right. Helium 2s1. This is going to be neon 3s1. This is going to be krypton 4s1. Did I do that right? Argon, sorry. Argon 4s1. Is that right? So write the notation for group 1, it is NS1. For group 2, it is NS2. Group 13, it's NS2, NP1. What is it for group 14? NS2, NP2. Are we comfortable writing N notation? Yes.
Wait, what is it 2 for NP2?
What? Group 14 has 2 electrons in its p orbital. No, I'm in group 14 here. It says 14. Is that right? Again, it is attention to detail. Please don't skip out on details. You will make mistakes. Rishali just thought group 18 was 14 was 18. All right? So, very likely to make mistakes. Can we go back to the warm-up? The warm-up says, what is the N notation for the arsenic group? What is the N notation for arsenic group? I need some student to help me. Yes.
NS2,
NS2,
NP3.
NP3. Are we good? If given an element, do you think you will be able to write its N notation? Are we good? Okay. We will get into quantum numbers. Yay. Finally. All right. Okay. I'm going to stop this lecture and I'm going to...
Bye.